Now our final examples involving division of radicals will involve radicals where the denominator is a binomial and one or both terms is a square root term. Now before we do that, let's look again at an example similar to those we've looked at earlier in this module involving division. And the first is 9 divided by 2 times the square root of 2. I'm sure you're pretty confident that we would need to multiply by the square root of 2 over the square root of 2 to rationalize the denominator. And so we will have then on the top 9 times the square root of 2. And in the denominator 2 times the square root of 4. So we'll have 9 times the square root of 2 divided by 2 times 2. And the final result will be 9 times the square root of 2 divided by 4. Now for our next example, we're going to be looking at rationalizing a denominator that's a binomial and where one of the terms is a square root. Now the trick here is to multiply the top and bottom by the conjugate of the denominator. Now do you remember what a conjugate of a binomial is? We talked about that a while back, and it's simply a binomial with the same terms but with the opposite sign between the terms. So what we'll need to do here is to multiply then the numerator and denominator by 2 minus the square root of 2. And so what will this produce then? Well, in the numerator, and I'm going to come down to the next line to continue, we have the 9 times the quantity 2 minus the square root of 2. Now our hope will be that when we multiply those two denominators now, that we will end up with an expression without a square root. So multiplying the first terms together, we have 4. The outer product, I think you can see, would be minus 2 times the square root of 2. The inner product plus 2 times the square root of 2. And if we multiply the last terms together, we will have then minus the square root of 4. So continuing, we have the numerator 9 times the quantity 2 minus the square root of 2. And in the denominator, we're going to have 4. And I think you can see that the two middle terms will add to 0. And the square root of 4 we know to be 2. So then we will have next 9 times the quantity 2 minus the square root of 2 all over 2. Now we're not able to reduce the fraction. Now we could distribute the 9 through both terms in the numerator, but this form or that form would be perfectly acceptable.